All right, we're going to graph tangent with the mother function. The mother function? Yeah, the mother function of tangent. See, check this out. I'm just going to graph the mother function really quick right here. And I'm going to put a point right here. And then you know what? I gotta look at this right here. You guys see the amplitude? Even though tangent doesn't have an amplitude, you see the number that's right in front of it? It's a -1. That means everything has to flip. So normally tangent would go right here, and then you would draw a line like that. But because there's a negative, we're going to put it down right here, and we're going to go like that. And notice I only went one space. Why'd I do one space? Because there's a -1 in front of it. If there was a different number, like a -3, I would have to count down 1, 2, 3 spaces from the midline to put my point. And then over here on the other side, since now we're going down like this, I got to put a point right here on this x, and then right here on this x would be the midline. And so that's how I kind of look at it. I look at it at each x. There's 5 x's to look at. The starting one, and then 1, 2, 3, 4. So there's 5 x's to look at. The middle one gets the asymptote. That is the mother function for tangent. And you can do this with every trig function. You can start with the mother function and then just start labeling your cheat graph. That's a cheat graph. It's a cheat graph because you're almost cheating. You just have to memorize what the mother function looks like and graph that first. And then deal with all the numbers. So let's deal with all the numbers. So to deal with all the numbers here, I'm looking at, I'm thinking about this template. It goes A, tangent, so A times tangent. And then B is a number that multiplies the x. The h is always inside parentheses. This one gets double parentheses because right now I have a b. And then you have your k. The a changes the amplitude usually. Tangent, however, doesn't have amplitude, but it does change these points. It changes how many spaces you count away from the midline. And then b right here changes the period. Okay, the period changes when you have a b. H is your phase shift or horizontal shift, and k is your vertical shift. Okay, so what the heck do we have going on right here? It looks like we have a -1 for the a, tangent, and then the 2 is multiplied into the parentheses. So the b right now is also inside that pi. So I'm going to take out the b. So I have to divide by 2. So 2x divided by 2 is just x, and then we have to go pi divided by 2. What's pi divided by 2? That's pi over 2. So now I can clearly see my b, and then I see my k. Oh, it's a 2. Okay, so what's my period? Well, because I have a b, I have to take the normal period of tangent and divide it by the b. The normal period of tangent goes like this. It starts at 0, and then we increase by pi over 2, pi over... No, wait, no, I'm sorry, that's right. All right, pi over 4. Let me just write it out. Pi over 4, and this would be pi over 2, and this would be 3 pi over 4, and this would be pi. So the normal period for tangent, actually cotangent also, they're kind of in the same family right there. The normal period is just pi distance. But our period is not pi because we have
2.
We have a b, a 2. And so you take the b, you divide pi by the b, so it's pi divided by 2. And so this is our period. It's pi over 2. Our phase shift is the h. I wouldn't know that h if I didn't take the 2 out. Maybe you did. Maybe you were insightful and you saw it. But this is right pi over 2. So we're shifting the whole function right pi over 2. Next we have, okay, we're going to do our graph. Okay, you only need those 2 things right there to finish all our stuff on here. Let's do the x's first, then we'll do the y values. The x's first. Your starting point is the phase shift. Okay, so we shifted to the right pi over 2, and then we have to count 4 times to get to this spot. This spot should be a distance of pi over 2 away from the beginning. You guys understand? It has to be a total distance of pi over 2. So what we do is we take pi over 2 and we divide it by 4. So I'm going to take pi over 2, multiply it by 1/4, because that's the same as dividing by 4. I get pi over 8. So I'm going to take pi over 8 and I'm going to add it 1, 2, 3, 4 times. And then this will be a distance of pi over 2. This needs to be a denominator of 8, so I'm going to cross out this 2 and make it an 8, and the top would be a 4. Right? Right. Okay, so that's 4 pi over 8, then it's 5 pi over 8, 6 pi over 8, and that one simplifies. And then we have 7 pi over 8, and then, what is that? 8 pi over 8? And so that's just pi, right? And that makes sense. That makes sense that this would just be pi, because if you were starting at pi over 2 and you add pi over 2, that should be pi, right? Okay, so there's all your x values. That part's done. What about my y values? Well, because we have a vertical shift, a vertical change. We have to put in that the middle line is the vertical shift. So we went down 2. So that's our midline. And then we have to go down 1 and then up 1 for our other points. So there's a point right there and there's a point right there. Now you could take this and transfer it over to a scaled graph. Start with the asymptote. That's usually the easiest way to start. So if my asymptote is at 3 pi over 4, I'm going to go over to 3 pi over 4 and graph this. Now, I know that 3 pi over 4 is right here, but let me show you guys or tell you guys why I know that. You see this right here? That's pi, and this is 0. Okay, if I wanted pi over 4, that means I have to split this up into 4 sections. And that would be right here, and right here. So that would be 4 sections. So this would be pi over 4, 2 pi over 4, 3 pi over 4. So I know 3 pi over 4 is right there. Okay, so I have that, and then what are my other coordinates here? We have, that is 5 pi over 8, that's 1 point, and this one right here is pi over 2, right? So I know pi over 2, we have this point on -2. And then I know between right here and this asymptote, that's where you're going to find 5 pi over 8. And so I'm going to go to 5 pi over 8 and go down 1 more. That's going to be that point. Okay. Now this is all I got right now, right? But I know this is supposed to go like this. So how do we find the other asymptotes? The asymptotes are what distance from each other? Pi? Pi? Pi over 2. Pi over 2. So if I go pi over 2 this way, I'll find my other asymptote. So I know that that's going to be right about right here. So now I know that my other point is going to be between this asymptote and this center. And so I'm going to put a point right here. And then I have my tangent line. Ugh. All right, there you go. And I just got to keep going pi over 2 and repeat it. So I go pi over 2. That would be right about here. And then I do my points. I go middle. Oops, wrong one. Right here. Middle. Drop down. Drop up. Get my line going. That's what it looks like. Okay, so what about the range? The range is -infinity to positive infinity. My y-intercept is kind of difficult to find, I think. No, wait, it's not. The y-intercept is going to be right there. I didn't draw that part of the line. I should have. So it'd be like right here, and then you go down like that. Okay, so we get -2 for my y-intercept. And then we have our x-intercepts. You can name all the x-intercepts on here. Actually, no, we can't. That's actually kind of difficult. We need the inverse tangent function to find this, so we're not going to do this right now. I'm just going to say nah. Okay, and then the asymptotes. Those ones are really simple to find. Our first one is right here, 3 pi over 4. So we can write 3 pi over 4, and you could kind of cheat and be lazy and just say, oh, you just have to add pi over 2 so many times, and that's how you find all the asymptotes. Yeah. Or if the problem said, specifically, you're in this window, you're from 0 to 2 pi, then you have to name each asymptote. So we would have 4 asymptotes that we would have to name in order to finish this problem if they gave us a window.